So today is the event of React, and this is a junior track. We're talking about different approaches. We've been talking about knowledge bases, about microservices and interactions, GraphQL, and different approaches. And now our very next topic is about tightening the full stack development loop with Nexus and Prisma. And well, the story is, so developing a real-world full-stack app often involves tediously threading data across multiple layers of the stack. This is particularly undesirable during prototyping phases, where the main goal may be just to demonstrate an idea of the design. And it's also risky when going to production, as data inconsistencies between the layers can lead to bugs. Oh, hell yeah, that's true. That's true. So using Prisma and Nexus together can help with the velocity and tape safety dilemma, that also providing an awesome development experience. Right. So we would like to welcome Ryan Chenkie. Hi, Ryan.
Hello. How's it going?
Okay, I can hear you very well. I can see you perfect.
Okay, great. Good.
Brilliant. Tell us a few words. What exactly inspired you for this particular topic? I'm asking it because I can see a lot of people. Every next session, every next event, the speakers on junior tracks highlight more and more interesting approaches to the vision. It's like they're talking to themselves in the past. So what inspired you?
Sure. Yeah. So, this talk today is going to be about how you can make your application more robust, and how you can move faster with development, and kind of take the prototyping stage of your application development all the way into something that's production ready. And the impetus for me to talk about that is really because, like, I've created a lot of applications in the past where I've moved quickly at the beginning and maybe forgotten to do certain things that are good for production, and those things can sometimes tend to end up in production and cause problems, cause errors once the application is out in the real world. So the more that we can prevent that at the very early stages, I think the better. And that's why I love these technologies that I'll talk to you about today.
Okay. Thank you. That's a good answer. And the thing is, I also wanted to point your attention that probably your web camera is stuck.
My which is stuck, sorry?
Your camera.
My camera is stuck.
Yeah.
Okay.
Yeah,
So my end seems to be coming through okay.
Okay, now it's back. It was freeze for a moment.
Okay, so hopefully, so I'm wired in to the internet here. I'm not on Wi-Fi, so hopefully this works out okay. But maybe ping me in the chat if things start to go sideways.
Sure. I'll ping you there, and then also 5 minutes before the speech end, I'm gonna raise a hand and I'll say 5 minutes left.
Okay.
2 minutes left. 1 minute left, and that's it. And in case if there's any urgent requests from the audience, I will also interrupt a little bit, but no that's problem. It. Okay. So, ladies and gentlemen, this is Ryan Chenkie. This is the tightening the full stack development loop with Nexus and Prisma. Go ahead.
All right, thank you so much. So yes, my name is Ryan. I'm a developer advocate at Prisma, and Prisma is all about making databases a lot easier to work with. If you're familiar with Prisma from the past, you might be familiar with how the company kind of started around GraphQL as a focus technology. And we still place a good amount of focus on GraphQL. We're very involved with the GraphQL community and all that's going on there. But the product itself now is not centrally GraphQL focused. It's really like if you've got a relational database, like a Postgres database or MySQL, we give you a set of tools to make it really easy to work with your database. So today I want to talk about how you can move really quickly in development, get your React application plus a backend, so an API with GraphQL, and a database, get all these layers put together in a way that is going to be future-proof for yourself, and also a really nice development experience to go along with it. So yeah, there's me on Twitter if you want to find me on Twitter at Ryan Chenkie there. And I guess maybe a way that we can start to conceptualize the problems that I'm talking about would be to talk about type safety. So this is a hot topic these days. TypeScript is becoming very popular. Lots of people are migrating to TypeScript. Some people aren't convinced of its benefits yet, but I am one of those people that is very convinced about what it has to offer. And if you're not familiar with TypeScript and the type safety you get from it, you could take a look at maybe this example here, where we've got this function. It's supposed to take two numbers, add them together, and give you a result, which is hopefully going to be a number. But as it stands with JavaScript, you can put any kind of types that you want into those two variable spots. So you might try to add 1 plus a string, which doesn't make a whole lot of sense. And you're going to get a runtime error from that. So you're going to get issues in production. You're going to get nan values, not a number. Hopefully those don't end up in your database and cause all sorts of corruption and problems. We can catch these kinds of issues early on if we think about moving to TypeScript. So with TypeScript, you would write your function something like this. In the spot there where we're taking number 1 and number 2, we are type hinting those to say that they should be numbers. So those two arguments, if we try to put anything else aside from a number in those two spots, when we call that function, we're going to get issues. We're going to get a type error. It's not going to compile for us. So that gives us a layer of safety that is early on in the development process. You are going to see these problems before you actually move your code to any kind of production environment. And this isn't a trivial matter to kind of just brush over, I don't think, because type safety has like real world costs. I think it has real world costs. If you're not doing it, the bugs that can result from it have real world costs, both in terms of like dollars and also like time spent debugging things that otherwise could have been caught by a type checker. And so these have author time issues, like you could lose time if you're not running type safety. You could lose time when you're authoring your code. Runtime issues can be there as well. You could you could run into problems where you're getting bad values, and in a runtime in a production environment, you're going to get a lot of problems. And I really like this talk. This is by Jamin Ferguson. He gave this talk called "Building Scalable and Dependable Node.js Applications." And so there's a link there. I'll link out to the slides after, where you can find this link, or you can just Google for this. It was a really good talk he gave. So working at PayPal, they had all sorts of problems that arose one day. They were getting pings about issues that were so errors that were showing up on the back end. And a pretty scary quote he says in his talk is, "We had no idea where the apps were failing. They were getting pinged constantly that there were problems, but they really didn't know what was going on." So he goes into how those problems were coming about, and effectively it came down to they had a function that was an important one that had been refactored recently, and instead of returning, I think how it went is instead of returning just like some kind of scalar value, it was returning a promise. And so the handling code when that function was called wasn't doing the async stuff that it needed to do to await that promise, and it caused all sorts of cascading issues. So that is something that can be caught early on in the development cycle if you are using a type checker. And these problems arise in a number of different ways, I think. It's not just like people, are lazy or anything. It's that you need to move quickly, right? So you prototype and you say, okay, well, we're going to make this more robust. We're going to make this better later on. And quite often that later on just doesn't really come. Requirements change over time, right? So people will set out building an application under a certain set of assumptions, and then later on those things are going to change. You're going to run into the case that you will have like new features that are required that behave differently, right? Also, as team size grows, the complexity in all of the stuff that goes into your developing your application stack, it's going to change. The surface area for invalid code is going to grow, right? So as team size gets bigger, so do potential issues that arise just from like people having disparate responsibility around the application. So when we're prototyping, we want to move quickly, and that causes a couple issues. So there's lack of documentation. This is another one of those areas where we say, okay, I'll go and add some docs later. And again, that later point often never does show up. We have a lack of good abstractions because we don't fully understand the complexities of the system. We don't understand how our code should be used in the future, or how it might be used. And this is something that I think is not so bad, because we don't want to have these hasty abstractions where we start writing convoluted code that handles every single case we can think of. But because we don't have the full picture when we're prototyping, it does lead to a spot where we don't have great abstractions over our code. And also, we have the kind of this lack of a solid knowledge base of our own code. There are changes and requirements that come along quite often, right? This is something that I've experienced many, many times. Things need to change with the code, how it's written initially. This leads to the issue of those bad abstractions starting to come to the surface. We see those abstractions starting to break down when we have to change things later on. Brittle code is an issue here. So code that really kind of easily breaks under the pressure of making our applications do more things than we initially set out to do. And this is a big one, is data models. Brittle data models can lead to the need for a rethinking of the way that our database operates, the way our API layer operates, and the way that our data is shaped. So on the team growth issue, this leads to the possibility, I think, for code misuse quite often. And what I mean by that is you'll have a developer that comes along and takes a look at the code base and says, okay, there's a function that looks like it does what I need it to do. So let me go and use it for that thing. Whereas maybe there's a subtle thing within that function. Maybe it's a large function because we didn't really break it out into small pieces like perhaps we should have early on. And that code can be misused, and perhaps it does something that it shouldn't do, leading to issues downstream, which can be tricky to deal with. We see things where we've got repeated code across the code base. Developers will write the same kind of code, maybe a little bit different, but the same kind of code in multiple places. And also we get this problem of like silos of knowledge. So certain developers know how part of the system operates, other developers don't really know, and we get this like diffusion of the domain knowledge of the organization, of the applications that are being worked on. So all of these are problems that exist kind of regardless. This is, part of the game, I think. But we can get a lot of benefits through type safety. And type safety, as I've already talked about, it's this way that you can set aside a whole class of issues, really, at development time that will make it easier for your developers to be confident about the code that they're writing. It'll give you confidence about what you're putting into production. And even though it incurs a little bit of a cost in terms of like time to ramp up when you're starting out with something like TypeScript, it really does help downstream quite a bit. So type safety, where is it applied? We've got these typical cases where you would have it applied to your front end, so your React application, becoming quite a popular thing to see React applications using TypeScript. Back-end code, so if you're thinking about a Node API, for example, you might be wanting to spin that up on TypeScript these days, and there's a lot of support for that nowadays. And then you've got the API access layer. So I'm thinking this is a bit different than type safety, how we might think about it in code, but the API access layer being the layer that is going to protect your API from receiving bad values, bad payloads, and invalid values. So this prevents people from kind of snooping around your API endpoints, trying to put in invalid parameters. And it also helps to just make your API more robust. The less typical spots where we would see this, though, would be database access. So typically when we think about database access, what do we think about? Maybe we've got some kind of ORM that helps us to access our database. Maybe it generates SQL queries for us. Maybe we're using raw SQL to access our database. And less typically, we see type safety around this. But this is an interesting area where newer libraries and also Prisma really come in handy, because we can get a lot of database type safety with very little effort. So where do we apply this? Front-end type safety might look like this. If you've got a React application and you've got some user component, you might want to set types for your props. So instead of just taking props in as an argument or destructuring them out when you are going to use them in your components, you can say that you want to tell at author time, you want to tell your components which kinds of props they can receive. So in this example for a user, that's name, which is a string, and email, which is a string. Anything else that we try to pass to this component is not going to be valid. So this is very helpful because now you can be more confident that your React components are being used in the way that you intend them to be used. We're not trying to pass invalid values. So there's a note here that TypeScript interfaces, TypeScript types, if you're going to use those in your React components, that is different than using prop types. So maybe you're familiar with React prop types. Prop types are going to kind of check against what is passed to your React component at runtime. Whereas with type safety through TypeScript, and we're using interfaces in this case for that, that's something that's going to happen at author time. So when you are writing your application, that's where you're going to see issues show up via TypeScript. So two kind of different purposes there between TypeScript and typical React prop types. Backend type safety might look like this. Same kind of thing. We've got this interface called user. It's got a name and an email. Those are the only two properties that should be on a user type. And then we might type hint the return type of a function. So, some utility function here called get user. This code now anticipates that the only thing that can be returned is an object with those two keys. And so that comes in handy when you are developing your backend, because you can be sure that the code that you're going to use to return data, for example, is going to be valid. So then database type safety. Again, this is something that we see less often. And one way to think about it is that we can have this type safety layer at the API where, like you see on the screen here, we've got some GraphQL going. We've got a type of user. It's got those two keys, name and email. We know those are supposed to be strings. The query type that we've got here says we can return a list of users. So that's API access. But when it comes to database, which often maps together, what we typically don't have is type safety around that. But with tools like Prisma, we get that, and we get it very easily. So this is what it boils down to when you want to have database type safety with Prisma, is you would give yourself a model, maybe it's called user, and it's got name and email, which are both strings in this case. So we're going to take a look at how all of this kind of ties together and how these things are threaded through the whole stack in just a second. But all this to say that managing all of these type safety problems, it can be a pain if you're doing things kind of piecemeal. So if you're just bringing in TypeScript to a project and you're trying to apply types to various parts of your application, that can be a bit painful. It can be time consuming, and maybe you don't really know exactly where to go with it. So if you're dealing with an API layer and you're dealing with a database, I would recommend trying this out. This is Nexus and Prisma. And we'll take a look at the demo here in a sec to see how it all works out. But if you've got needs for type safety, and I recommend that you consider type safety, and you've got a need for an API layer and a database layer, Nexus and Prisma go really well together because they do a lot of work for you, which we'll take a look at. And with that, we can take a look at the demo here. So what we'll do, I've got this application here that is basically just a little API that is going to return data about posts. So let's consider this an API that is going to give us blog post information. And the use case for this, could be for any kind of React application that we might have. This is a Node application here. It's using TypeScript, and we're going to see how we can use Nexus and Prisma together. And so maybe it's useful to kind of give the give the introduction to what Nexus is, for example. And Nexus, if you're familiar with GraphQL, you might be familiar with how you write your GraphQL API, if you're familiar with building GraphQL APIs. And you would typically do so by writing schema definition language code. You would say that maybe you've got so it could look like this, where you've got a query. I'm going to do this in strings because you typically do this. If you're using the schema definition language, you might give yourself a type, and that might be a type of post, and it has, an ID, And it's got also a title, a string, and it's got a body, right? So we might be familiar with how to do this with the schema definition language. Nexus, and so when you do this, you also need to wire up a set of resolvers to tell your backend how to resolve your data out. Nexus takes a different approach. It's still going to give you a GraphQL API, but instead of writing schema definition language, you write in what we call a code first fashion. So we can take a look at what that looks like. I'm going to give myself a constant of post, and that's going to be equal to an object type. And I'm going to say that the name of this type is called post. And then down here below name, I'm going to give it some definition. I'm going to say that it should have an ID field. We're going to call it ID. I'm going to say it needs a string field called title. String field called body. So those are the things that are necessary to go into a post. So now we need a query type to resolve this data out. We'll give ourselves a constant of query. That's going to be object type as well. Query, and we're going to have some definition here for it as well. We'll have a t.list.fields. This is going to be, this says give us back a list of a certain field, and we're going to call it posts. The type that we want to resolve out here is going to point to post, which we have defined up here. So this is going to say, give us this query type where we return a list of type post. And then we can resolve some data out. If you're familiar with resolvers on your GraphQL backend, resolvers are kind of what you can consider the handler for your queries. You are going to, in your resolver, perhaps go out to your database, get some data, maybe you need to shape it in a certain way, and then you can return it to the client. So when we resolve here, we can, for now, let's return, maybe we'll have like ID is going to be 1, and title can be my first post, and body can say first post body. All right, so let's see if we're going to get anything good here. Start my TS server, just make sure we're good on this. And then if I'm over here in GraphQL, I need to add, so the thing that I forgot to do here is I need to add those things to my types here. So types here, I want post and I want query. Back over here in my GraphQL playground, I can go query for my posts. And so I've got my data and I've got my posts here. So this is cool, but this is just giving us static data right now. And what we want to do is get a database wired up, and we can do that with Prisma, and we'll see how to do that very easily. What I'd like to show you here is, because I've got this all running through Nexus schema, I'm getting these generated files. So I've got something that's being generated called schema.graphql and nexus.ts. And if I go to the generated folder here, here's schema.graphql. So this looks like what we've seen before. This looks like that schema definition language. And so what Nexus does is it takes your code first GraphQL API definition, and it'll spit out a schema for you. And this becomes useful because now you can pass this schema definition language file to different places where it can be used. For example, your React frontend. If you're using VS Code or other editors that support this, you can use certain plugins for GraphQL to take in this schema definition language and say, okay, based on what I have here, give me type hints about how I can make calls to my GraphQL API. So if you're on your React frontend, you'll be able to know what your backend is shaped like through your editor, which is quite a nice way to go here. The other thing we've got is our nexus.ts file, which is going to give us our types. If we take a look for post here, we have got information about our post. So there we go, body, ID, title. All right, so there's our generated types. We get that at low cost with Nexus, and that makes for quite a nice development experience. Let's go now, and we are going to wire up Prisma. So if I go over into a new terminal window and I do Prisma init, what I've got over here now is this folder called Prisma. It gives me two things, an environment file and a schema.prisma. And schema.prisma, this is the Prisma schema language, as we call it, is the place where you are going to define your database. I've got a Postgres database wired up in the background, so I'm just going to flip over to the credentials that I should be using. And my database is called blog posts. Save that and come back over to schema.prisma. And the way that you can sort of think about this is you can start defining your tables right here in this file. And really all that it takes to do so is something like this. Give ourselves a model called post. The first field that I want here is going to be an ID. I want that to be a string, and I want to use this decorator called @ID to say that this is the primary key for this table. And I also want to give it a default value. I want it to default to a collision-free universal ID, so kind of a short string for an ID. This could be an int, though, if you want to auto-increment your IDs. It could be a UUID for universal unique ID. But those are some of the options for ID. The other thing that we would have here would be title. That's going to be a string. And we also want body, which will be a string as well. All right, so we've got our schema.prisma file there. I'm just going to make sure that I save my environment file. And the next step here is to get our database migrated. So what we can do for that is say Prisma migrate, and we'll want to save what we've got. And we're using the experimental flag here because this is a feature that is under experiment. You can think of it as used with caution. Still, like, you can use it, it works well, but it's, used with caution and subject to change, that sort of thing. We'll say that this is the initial migration. When I run that, we get this migrations folder here, which gives us a bunch of stuff. It gives us a README with the steps that we need to take to execute that Prisma model. And the first step we need to do here is to create that table. What we can do now is say Prisma migrate up, which is what we need to do to actually get that table to go into our database. Prisma migrate up, we'll run that. And now if we take a look over at our database, this will probably be a little tricky to see because I can't zoom in this table plus client, but I've got post here. So this is my post table. It's got the ID, title, and body up top. I've also got this migrations table, which is generated by Prisma and talks to it about the migrations that have already been run. All right, so the last step that I want to do here is say Prisma generate. And when I do Prisma generate, what's really cool here is that I go into my node modules, and in the .prisma directory, if I take a look at index.d.ts, I get a whole bunch of generated code that is going to give me things like information about how to use posts. So let's look for example. We'll look for type post. Here we go. We've got a type called post, and it gives us those items that we already talked about for how our post information should be typed. And now I've got this really type-safe way of using my database. And we can take a look at how we would do that if we come down and we say const mutation. I want a mutation now to actually create some data. So mutation is going to have a type of mutation. And we are going to want a few things on our mutation here. It looks a little bit different than how we would do queries. We give a definition as we typically do, and we want to say t.field, call it create post. That's the task here, is to create a post. The return type, what we'll get back after, is going to be a post. And in this case, we need some arguments. We need some data that gets passed to this mutation to actually operate on. We'll want title. That's going to be a string arg. And we'll say here that nullable, so actually we won't say nullable true. In this case, we'll want this to not be a nullable item. And we'll do string arg for body as well. So there's our arguments that can be passed in. We still need a resolver to tell our mutation how to operate. And if you're familiar with resolvers, if you've done stuff with Apollo, for example, it looks the same way. We've got the 4 arguments. We've got parent, args, context, and info. Those are the 4 arguments on our resolvers. And in the argument spot, I'm actually just going to destructure out title and body, just like that. And then these, like info, for example, doesn't get used in this case. So I'm going to take that off. And I could in here start to use Prisma directly. First, I've got to pull it in though. And so what I want to do is say import Prisma client from @prisma.client. And then I need to new up a Prisma instance, which I'll do by saying const Prisma equals a new Prisma client. And so with that Prisma client, I could just come in here and say Prisma and use it directly, but I'm actually going to put it onto context so it can then be passed around throughout my API. To do that, I'm using Apollo server down here, and I can operate on the context down here, and I'll just say I want to include Prisma on my context there. So if I'm over here in my resolver, I can say return context.prisma.post. So we get our post type that's type hinted on Prisma. And then we've got this method called create. And what we'll see here is if I want to create something, I've got to be very specific here to give it exactly what it wants. So I can pass in title and body, but if I tried to pass in something like author, and I tried to say that's me, you'll see here that I'm getting the red squigglies, and that's because the types that are associated with this post model do not allow author to go in there. So I can only give this create operation exactly the data that it should have.
Left.
Okay, thank you. And so it becomes very tricky, becomes very difficult for me to write queries that are invalid, which is a great help when you're going to production because you can be more confident that your database calls are doing what you want. Okay, so context.prisma.post create, give it some data, which is title and body. Let's save this. I'm going to add mutation here to my types. And let's see here. Does that give us anything good? Oops, I should say name is mutation, not type. All right, so in theory, if we come over here now, we should be able to do a mutation. So we'll say we want a mutation. We want the create post mutation. I want title to be my first post. I want the body to be my first post body. All right. And then we want to return something. We'll return the ID, we'll return the title and the body once we're done. If I hit play, there we go. We have a post created. It got an ID that was generated for us by Prisma. And now just really quickly to wrap things up, we can go and see how to get those posts out. So when we're querying for our posts, instead of returning this hard-coded information here, let's do this. We'll get our context. And we'll say return context.prisma.post. And we've got this find many method here. So these types that are associated with post will give you exactly the database operations that you want to do. All right, so let's save this and we'll head back over. And now if we ask for posts and we go for ID, title, and body, I'll clean that up here. There we go. We've got our posts, and we've got that one that we just created. So this, gives us a way to be type safe at our API level, at our database level, and we get things that are generated for us, which are going to be helpful in our React applications. We get the schema.graphql. This is useful in your editor to tell your React app what it can query for and the mutations you can do. And then we also got these types generated by Nexus. This gives us information that's useful in our React app as well. And then when it comes down to it, this Prisma, these Prisma types that we get generated for us here are going to be super useful. You can import these as well and apply type safety across your whole application stack. And as you probably are picking up on, it's really easy to wire up a database with Prisma. And once you get going here, you define your tables, you define your relations, and you've got your whole database wired up in a type safe way that is going to be great for the whole application development cycle. So that's about it. I am here on Twitter at Ryan Chenkie. You can get these slides at this link. It's bit.ly/nexus-prisma. That is all I've got for you today. So I think I'll probably hand it back over to Charlie now.
That's
Thank you, Ryan.
brilliant.
There
Thank
you
you,
go.
Ryan.
Yeah, no problem.
That was just amazing. Okay, so I've heard your I've heard your topics, and I liked the way how you expressed it. Tell me, please, is that your first online conference, or you look actually quite experienced in that?
Is this my first online conference? No, I've done a few of these now.
Mhm.
I think the first one that I did was kind of when the pandemic rolled around. I don't think I had done a an online conference prior to that.
Yeah,
But now that we are in this pandemic world, I've definitely done a fair share of these online events.
thank you. Yeah, me too. Actually, I've never had any online conferences like this before. Maybe just only the online meetings, with my teams.
Yep.
Now tell me, please, how do you feel about like the whole presentation, and what's the biggest difference between talking to the live audience and to the virtual one?
Yeah, so the biggest thing, and it's taken me a while to get used to, I think I'm doing a better job with it now, is there's no feedback. There's no live
Yeah.
feedback from the audience in terms of body language and people
Hmm.
maybe yawning or looking bored
Yeah.
or being happy. So it feels like I'm talking to my computer, which I suppose I am doing. But it is also being transmitted through the interwebs as well, and so it's different because you don't have the same kind of ability to
Right.
respond to people's reactions in the same way, right? That's the biggest difference. I think it's the thing that I miss about going to in-person conferences, of course, too, is the hallway track, as we call it, the ability to just chat with people outside of the actual presentations and really start to be part of a community in that way and have these
Yeah.
in-person interactions and relationships. I miss that for sure.
Thank you. That's true. That's the overall pain of it. However, there's a few ways coming up these days how to resolve this. One
Mm,
of them is actually to simulate. If you are alone, you can simulate all the reactions of the audience
mm,
by this. So usually there are three different main groups. Let's say that represent any audience. That's the conformists. It means the people that already like what you say, and that's cool. That's okay. They support you, and
mm.
that's important. Then there are rebels that are always against whatever you say. They
Sure.
will criticize that, and there are opinion leaders
Mhm.
that they can be one or a few of them that shows the reaction, and they actually attract them, both the rebels and the rest of the audience. So if you talk to the rebel and to the opinion leaders, in most cases you will get the appropriate path through the
Mm.
people's opinion. So the technique is to simulate it is just to have a few different stickers of different sticky notes of different colors,
Interesting.
let's say,
Yeah.
and put any reactions there. Let's say a surprise reaction or something like,
Yeah.
"Oh, what you're talking about," or whatever. So just have a few stickers of each kind with different reactions, and then you can set also a timer, and each time up to 3 minutes, sometimes even faster, you can randomly drag one of the stickers
Mm.
out of the table and react to that emotion. In most cases, you can really predict um, like the most popular reactions, so you can simulate them really very well. Well, the second approach is much easier. Just ask someone of your friends to support you and to sit along with you on the background, or
Yeah.
even the opposite to your camera, and just sometimes react to what you're talking. So it's going into a dialogue.
Yeah, that's interesting. That's maybe I'll give that a shot. I'll see how that works out. That's I hadn't thought about an approach like that, giving yourself a simulated audience reaction set.
Yeah,
That's really cool.
give it a try and let's see where it goes.
Awesome. Thank you.
Cool. Look, we have more speakers now.
Okay.
However, there is a Q&A panel session starting at 15 UTC time, which is actually right after the next speaker. We'll be waiting for you here, and we collect the questions from everywhere. So, guys, people, please feel free to ask your questions in the comments. Thank you, Ryan. See you soon.
All right. Bye bye. Thanks.
Bye bye.